Ever looked up at the sky and wondered what those clouds are telling you? From fluffy white cotton balls to dark stormy giants, clouds are more than just decoration, they're nature's weather forecast. In today's video, we're breaking down the different types of clouds and what kind of weather they bring, whether it's a sunny day ahead or a thunderstorm brewing. So if you've ever wanted to read the sky like a pro, stick around, because by the end of this video, you'll know exactly what to expect just by looking up. Cirrus clouds are high-level clouds that form at altitudes above 6,000 meters. They are typically composed of ice crystals rather than water droplets due to the low temperatures found at such elevations. Because they are so high up, cirrus clouds are often blown by high-altitude winds. Cirrus clouds appear as thin, wispy strands and are often white in color. They can resemble feathers, horse tails, or fine brush strokes stretched across the sky. Cirrus clouds are usually scattered and isolated, though they can cover large portions of the sky as a weather system approaches. Cirrus clouds do not produce precipitation that reaches the ground. However, they are often associated with incoming weather changes. When cirrus clouds increase in number and thickness, they may indicate that a warm front or storm system is on its way, usually within 12 to 24 hours. Cirrocumulus clouds, similarly to cirrus, form at heights above 6,000 meters. Like other high-level clouds, they are composed mostly of ice crystals, although some supercooled water droplets may also be present. These clouds appear as small, white patches or ripples, often arranged in a regular pattern that can resemble fish scales. The cloudlets are usually smaller than a fingernail held at arm's length, helping to distinguish them from lower-altitude lookalikes like Altocumulus. Cirrocumulus clouds do not produce precipitation that reaches the ground, and they are typically associated with fair but cold weather. However, their presence, especially when widespread, may signal instability in the upper atmosphere and can occasionally precede a frontal system or storm development. Unlike cirrus, cirrocumulus clouds tend to be more textured and patterned, giving the sky a more layered or quilted appearance. They are relatively short-lived and often change quickly, due to shifting upper-level winds. Cirrostratus clouds form above 6,000 meters and are composed entirely of ice crystals. They are typically thin and uniform, often covering large portions of the sky with a milky or translucent veil. One of the most distinctive features of Cirrostratus clouds is their ability to produce optical phenomena, halos, circular rings of light that appear around the sun or moon due to the refraction of light through ice crystals. Cirrostratus clouds are often difficult to see directly, because of their thin, almost transparent nature. However, their presence can be detected by the diffused, hazy appearance they give to the sky, or by the halo effect they create. These clouds usually indicate a change in weather, most often the approach of a warm front or a low-pressure system. Their arrival, especially when followed by thickening and lowering clouds, may suggest that precipitation is likely within 12 to 24 hours. Cirrostratus clouds differ from cirrus, in that they blanket the sky rather than appear in streaks or wisps, and they differ from cirrocumulus by lacking a rippled or patchy texture. Altocumulus clouds are mid-level clouds that typically form between 2,000 to 6,000 meters above the ground. They are composed mainly of water droplets, though they may contain ice crystals at colder temperatures. These clouds often appear as white or gray patches, sheets, or rounded masses. The cloudlets often look like cotton balls or rolls, and are arranged in layers or groups, sometimes forming a wave-like or ripple pattern across the sky. Altocumulus clouds are commonly associated with fair weather, but their presence, particularly when seen on a warm, humid morning, can indicate the potential for thunderstorms later in the day. Widespread altocumulus preceding a cold front may also suggest changing weather conditions. These clouds do not typically produce significant precipitation, though light sprinkles or virga, rain that evaporates before reaching the ground, may occasionally fall. Altostratus clouds, similarly to Altocumulus, form between 2,000 to 6,000 meters above the Earth's surface. They are composed mainly of water droplets, though ice crystals may be present in colder layers. These clouds appear as a uniform, gray or bluish-gray sheet that often covers the entire sky. Altostratus clouds are generally featureless, with a smooth or slightly fibrous texture, and can create a dim appearance of the sun or moon, which often appears as a bright spot behind the cloud layer. Altostratus clouds are typically associated with large-scale weather systems, such as warm fronts or advancing low-pressure areas. Their presence usually indicates that precipitation is approaching, especially if they gradually thicken and lower over time. While altostratus clouds may not produce significant rain or snow themselves, they often precede steady precipitation, which may fall from thickening layers below. Any precipitation that does occur is usually light and continuous, rather than heavy or showery. Altostratus clouds differ from Altocumulus in that they appear more uniform and widespread, lacking the distinct individual cloudlets seen in Altocumulus formations. Nimbostratus clouds are low to mid-level clouds that typically form between 600 to 3,000 meters, though their base can be lower during heavy precipitation. They are composed of water droplets, with ice crystals in colder upper portions. These clouds appear as thick, dark gray layers that often cover the entire sky, creating a dull, overcast atmosphere. Nimbostratus clouds are dense and formless, with no distinct structure or edges. They block out the sun or moon completely, leaving the sky uniformly gray. Nimbostratus clouds are best known for producing continuous, steady precipitation, either rain, snow, or sleet, depending on temperature. Unlike cumulonimbus clouds, which are associated with intense but brief storms, nimbostratus clouds bring long-lasting, widespread precipitation that can persist for many hours. These clouds usually form in association with warm or occluded fronts, where warm moist air is lifted gradually over cooler air, resulting in extended periods of cloud cover and rainfall. Nimbostratus differs from altostratus by being thicker and darker. Stratocumulus clouds are low-level clouds that typically form below 2,000 meters. They are composed mostly of water droplets, and occasionally contain ice crystals in colder conditions. These clouds appear as large, rounded masses or rolls, often arranged in clumps or layers that can cover parts of the sky or stretch across it entirely. Stratocumulus clouds are usually gray or white, with darker shading on the underside, giving them a textured, lumpy appearance. Spaces of clear sky may appear between cloud elements, especially in broken layers. Stratocumulus are not associated with significant precipitation, though light rain or drizzle can occasionally fall from thicker formations. They often form after the dissipation of heavier rain clouds like Nimbostratus or Cumulonimbus, and are common in stable atmospheric conditions. These clouds tend to be low and flat, giving the sky a soft, overcast look. Unlike stratus clouds, which are more uniform and featureless, Stratocumulus show more structure and variation in tone and texture. Stratocumulus clouds can occur in many weather scenarios, including cool, moist mornings or behind cold fronts. While they often bring dull or cloudy skies, they rarely signal severe weather. Stratus clouds are also low-level clouds that typically form below 2,000 meters. They are composed of water droplets, and in colder temperatures may also contain ice particles. These clouds appear as a uniform, gray blanket that covers the sky completely, often creating a dull, featureless overcast. The cloud base is typically low and flat, sometimes appearing to sit just above the ground. In fact, when stratus clouds reach the surface, they are classified as fog. Stratus clouds produce little to no precipitation, though light drizzle or mist is possible. They are often associated with stable air, forming in calm conditions such as cool mornings, coastal environments, or beneath a moist inversion layer. Unlike Stratocumulus, stratus clouds lack texture or variation. They are smooth and continuous, with no visible cloudlets or breaks. They differ from Nimbostratus in that they are thinner and do not produce steady widespread rainfall. Stratus clouds tend to give the sky a gloomy or gray appearance, but their presence generally indicates calm, stable weather, rather than storms or fronts. Cumulus clouds are low-level clouds that typically form below 2,000 meters, though larger forms can grow into mid- or even high altitudes. They are composed mainly of water droplets and are among the most recognizable cloud types. These clouds appear as puffy, white cotton-like heaps with a flat base and billowing tops. Their tops often resemble cauliflower or domes, rising vertically due to convection, the upward movement of warm air from the Earth's surface. Cumulus clouds generally form on sunny days, especially in the late morning or afternoon, when the ground heats up and moist air begins to rise. They are associated with fair weather, especially when they are small, isolated, and well-spaced, a form known as cumulus humilis. While typical cumulus clouds do not produce precipitation, if conditions are right and they continue to grow vertically, they can develop into cumulus congestus or cumulonimbus, which are capable of showers or thunderstorms. Cumulus clouds are distinct for their bright, sunlit tops and sharp outlines, especially against a blue sky. They differ from stratus clouds by being detached and vertically developed, rather than flat and featureless. Cumulonimbus clouds are towering, vertically developed clouds that span multiple levels of the atmosphere, from low altitudes below 2,000 meters to heights exceeding 12,000 meters or more. They are composed of water droplets in the lower portions and ice crystals in the upper reaches, due to the extreme range in temperature with altitude. These clouds begin as ordinary cumulus clouds, but undergo rapid vertical growth in unstable atmospheric conditions, driven by intense upward convection. As warm, moist air rises and cools, it fuels the formation of a massive, dense cloud column that may eventually reach the tropopause, the boundary between the troposphere and stratosphere. Cumulonimbus clouds are easily recognized by their towering, anvil-shaped tops, the result of rising air hitting the stable layer of the stratosphere and spreading horizontally. The cloud base is typically dark and low, while the upper regions appear bright and white when illuminated by the sun. These are the only cloud type capable of producing severe weather, including heavy rainfall, thunder, lightning, hail, strong wind gusts and in rare cases, tornadoes. Precipitation from cumulonimbus clouds is often intense and short-lived, falling in localized areas. Within or near these clouds, conditions can become turbulent, with strong updrafts and downdrafts, posing serious hazards to aviation. Cumulonimbus clouds are associated with cold fronts, surface heating, and convective instability, and may develop as isolated storm cells or as part of larger thunderstorm complexes such as squall lines or mesoscale systems. They differ significantly from all other cloud types in their vertical extent, weather severity, and dynamic structure, making them a key feature in forecasting and atmospheric science. And that's a wrap on the different types of clouds and the weather they bring. Next time you look up at the sky, you'll know whether to grab your sunglasses or your umbrella. If you found this video helpful, don't forget to like, subscribe, and hit that bell so you don't miss more sky-high science just like this. Thanks for watching, and until next time, keep looking up.